we recall the definition of a singular point set 0 of a function f of z. A criteria for being a singular point is that the function is not analytic in the point, so it's not analytic in the point set 0 here, and for any circle centered at set 0, there exists at least one point inside the circle where the function f of z is analytic. We have special classes of singular points, for example, isolated singular points. F of z is not analytic in the point set 0, of course, but there exists a circle with center at set 0, such that the function f of z is analytic at all points interior to this circle, of course except at set 0. So let's take some example of this. This function, a rational function, cannot have any zeros in the denominator, so we have several singular points. In this case, the zeros of this denominator are 0 and plus and minus I. And all these 3 points are isolated singular points of the function f of z. Why is that? Well, let's take this singular point set 0 equal to 0. Then we know that we can find a circle, for example, a circle with radius equal to 1/2, centered at this singular point 0, such that all points inside this circle are analytic, except at the point set 0. And the same for the other singular points, I and minus I. We can make the same circle with radius, for example, equal to 1/2. What about this? We know that the principal logarithm of z is analytic in the complex plane except on this line. So when the real part is equal to 0 and the imaginary, this should be opposite, x should be less than 0 and y should be equal to 0. So on this line, the function is not analytic. Therefore, and we know that if we take any circle on this centered at some point on this line, we will find points where the function is analytic inside this circle. So it's a singular point, but is this isolated singular points? No, it's not, because we cannot find any, for example, on this point -3, the function is the function is not analytic at -3, but we cannot find any circle where the function is analytic at every point except at the point -3. So therefore this is not a isolated singular point. So the principal logarithm of z has singular points on this line, half line, but there are no isolated singular points. Sorry for this mistake. It should be less than 0 and y equal to 0. What about this? This function f of z equal to 1 over sine of pi over z. Is that an a function with isolated singular points? Yes, it says a lot of singular points. Let's just try to find them. We know that this function is analytic except when the denominator here is 0. So when the denominator is 0, then we have some singular points, and let's find these singular points. Sine of pi over set equal to 0 gives that set must be 1 over n, where n is some positive integer or negative integer, like this. So inserting this into the 1 over n, replacing set by 1 over n, then we obtain n times p. Sine of n times p is equal to 0. We know that when n is equal to 0 here, we have some it should be not equal to 0, because then we have a 0 in the denominator here, so set is equal to infinity. So but for n equal to 1, 2, 3 and 4 and so on, we know that we obtain a sequence of singular points like this, starting here n equal to 1, then set is equal to 1 over 1 here, and when n is equal to 2, we have set equal to 1/2, n equal to 3, we have set equal to 1/3, and so on. And when n is going to infinity, the set value, corresponding set value, or the isolated singular points, converges to 0. But we know that all of these points for any value of n, integer value of n larger than 0, we know that we have isolated singular points. Because, for example, here we can make a circle around this point 1/2, which has radius small enough such that this circle does not include any other singular points. Therefore, 1/2 must be a singular, isolated singular points. And the same for any of the other values of 1 over n. Except the case when set is equal to 0. Because what's happening then? This cannot be an isolated singular points, because we know the function is not analytic there, but any circle with center at set equal to 0 will contain infinitely many isolated singular points. So therefore set equal to 0 is not an isolated singular point. Okay. All others for n larger than 0 or less than 0 are isolated singular points.